Greetings, everybody. This is Eric Andelin, Senior Workflow Specialist with SimActive, and you're joining us for the webinar, Cameras on Drones and Aircraft. Is Bigger Always Better? And with me, I have my guest, Kevin Graville, Systems Sales Manager with Phase 1. Kevin, say hi to everyone.
Hey, everyone. I'm glad to be here. Thanks for having me, Eric.
Yeah, absolutely. So, for the audience, they don't know, we're going into September with Commercial UAV Expo. Kevin and I were just at MAPS, the summer meeting in New Hampshire. So we started chatting about new technology, what's coming out with Phase 1, things like that. But I thought it would be good to have Kevin in and join me on this webinar and talk about some of these topics. So Kevin, do me a favor and just introduce yourself to our guests.
Yeah, for those of you that don't know me, as Eric said, my name is Kevin Graville. I work for Phase 1 in the Manned Aerial Systems Sales Department for here in North America and South America. I have colleagues around the world. For those that don't know a whole lot about Phase 1, our main headquarters is in Denmark, and we have our manufacturing facility in Japan, where we can, make everything, put all the components together, and make the fabulous cameras that we do. And then, of course, we have support based right here in Colorado, and new calibration lab that just opened up, and we're really excited to be supporting the North America users of Phase 1 cameras. We have cameras that go from the drones, as we're going to be talking about here today, manned aircraft, which is my passion, and of course we have cameras that now go up into space. So we cover a lot of the realm of aerial imagery and even outer space imagery. So excited to be here and talk to you about that.
That's actually fantastic. It lines up exactly with what SimActive does. I mean, we actually started in the satellite world and worked our way down. Of course, my background is in aerial photography and survey and mobile Lidar and all that stuff. But I still have a passion for the aerial photography side of that as well. So being in sales and working with Phase 1, I mean, wow, what a slam dunk. You guys have got an excellent product. The boys in Denmark are making great stuff. And I know from my perspective, being that a lot of Phase 1 sales lead or are in combination with SimActive sales with Correlator 3D. So I know you guys are selling a lot of cameras, and that from all of the data sets that we see from our customers, I can attest that it's an outstanding product. We love it when somebody calls us and says, I'm working with a Phase 1, because we know they're 80% past the battle already. So in this webinar, again, cameras on drones and aircraft, is bigger always better? And it kind of came up before we got together at MAPS. There's a new Sony camera out there that's like a 61 megapixel camera. So that doesn't really make it medium format, but it doesn't really make it small format. So, we started having the conversation of, what are the defining lines between small, medium, and large format? What makes a camera, just a, off the shelf store-bought camera versus another camera? And so we thought this would be a good time to revisit these topics and have an expert like you involved in this. And you can take expert with a grain of salt. Just like I'm a professional, you can take that with a grain of salt. But I thought we would get into this conversation more so than, those of us that were at MAPS talking about it. So the topics that we're going to cover are as follows: analyzing different camera types and sizes available, understanding the factors affecting camera quality, selecting a camera for photogrammetry, and then processing data from any camera with correlated 3D. So
Certainly.
let's talk a little bit about analyzing different camera types and sizes. We almost put you guys in the bucket of medium format, and that may or may not be wrong, but I've always thought that a small camera is a camera that typically is attached to the drone when you buy it, whether that's a DJI or one of the other brands. It's the camera that comes with the drone. Medium format would be, so back to the small format. Small format could also be, a cheap Nikon or a cheap Sony camera. And I don't mean that they're cheap in a sense that they're not of good quality. I mean that they're not expensive and you can run down to Best Buy and get one. So to me, that's still probably small format. And then medium format is where actually somebody designed a camera for the purpose of mapping. And it's of a high enough resolution that you can fly in an altitude, above 1,000 feet, 700 feet, something like that, and capture good data. And then large format, of course, is what you would see in, aircraft, something you would see like an Intergraph camera or a Zeiss camera or something like some of the old film cameras. So, give me your thoughts on, where you see that spectrum.
Yeah, I think you hit the nail pretty squarely on the head with that. One of the major definitions of a medium format sensor, the physical CMOS or CCD sensor, is the physical size of it. The small format cameras are typically more 35 millimeter film equivalent.
Yep.
And then of course the medium format is going back to like the 70 millimeter film or some of those, the technology is such that it's equivalent to those types of film sizes. And of course,
Okay.
the large format being that, 10-inch film that we all knew growing up.
Okay. That makes more sense. And, it's been a while. It's been a long time since I've dealt with film. So I don't even, I don't even reattach that when I think of size, but absolutely right. 35 millimeter, 70 millimeter, and 9 or 10 inch makes sense for the definition. That's pretty good. In the medium format world, from the mapping perspective, I think, from the mapping perspective, we would think that maybe Leica started it with some of their smaller cameras, and other than that, especially since the digital world, it's pretty much been you guys and not very many others. So that's pretty cool, and the fact that team in Denmark recognized that, and I know they were doing, tell them a little bit about camera. How did phase one go from, what was their original cameras, and how did they to come to the idea that, hey, this we should be looking in the mapping world?
Yeah. So phase one was one of the first camera manufacturers to put a digital back onto, basically a film camera to kind of scan during the collection phase. It was kind of a scanning back, if you would. And so phase one has been doing that for, well over 30 years now. So we've been involved with digital imaging for many, many years. And, phase one actually has kind of 3 tiers of, our business focus, with geospatial being, probably the largest of the 3. But we also have bespoke photography, which is, the high-end fashion photography, marketing photography, for magazines and things like that. And we, that's a really strong division. And then we also have a division that does cultural heritage. So, photographing books in museums and, just capturing, culture throughout the world. So that's a really important part of our business as well. And you got to have all the finite details to maintain those pieces of history that otherwise will be lost and just continue to deteriorate no matter what we do. It's just the nature of time. But back in 2012, we were approached by a company that said, "Hey, we like your cameras. We want to put them on an airplane and take some photography." Okay, and because of that, we've now grown into having the ability to have complete systems with a Planix IMU and a flight management system. The individual cameras that can be paired with Optech and Regal Lidars. That's the large majority of companies out there have a Phase 1 camera with their products, and their Lidar sensors. And we're just happy to continue that tradition as far as seeking out the best quality imagery that we can from the technology and trying to stay on the cutting edge of what aerial survey can do and what you can see from an airplane.
Very cool. Very cool. And yeah, we'll get to that as well. When we talk about cameras, we're also these days talking about integration and how those cameras integrate with IMU, the airborne GPS, and LiDAR. And we see a lot of that. I mean, we see a lot of LiDAR sensors that are mated or tied to your camera as well. So that's really cool stuff. So that being said, so we've talked about camera size, and let's talk a little bit about the factors that affect camera quality. In cameras in general, just the basics of cameras, lens quality. I mean, that's a big deal.
Huge deal.
And again, when we talk about drones, the lens that comes on the camera of the drone that the manufacturer provided it's not necessarily the greatest lens in the world. And it may vary, you buy one and then you buy another one, and there may be a big variation in the quality of that lens. I know in the medium format world and in the large format world, going back to when I was a kid sitting in the back of the airplane, operating the camera, those cameras had to be calibrated. They had to solve for all of the issues with the lens, so you knew exactly all the parameters, and they spent a lot of time creating those lenses. With you guys, it's the same, correct? I mean, we're not talking about Joe Bob's Nikon lens strapped to your product. You guys build your lenses as well. Is that correct?
Yeah, that's correct. We manufacture and fine tune the lenses there in the factory in Japan, and it's quite the process. I've yet to have the pleasure of going and seeing it firsthand, but I've seen some videos from the things they do, and it astounds me at what they're able to do over there.
Yep. And you talked about the differences in camera size, but what we're really talking about is how much information that CMOS can capture, which in turn leads to how high technically fly and still capture data specification that's required. So, I mean, a little bit about your guys. Like you said, you're the first to create the digital camera backs. So, tell me a little bit more about that.
Yeah. Well, and it all has to do, of course, with the resolving power of the lens and mating the CMOS sensor with the best possible lens combination. That's why you don't just have an adjustable focus lens. It's a fixed focus lens. You can have a very finite measurement on your principal point of the camera. You can map out the MTF data of the lens so that exactly what issues are in the lens. I mean, every lens, no matter how perfect the glass is going to have, some sort of anomaly that has to be solved for. That's just the nature of it. And then, we use a fairly industry standard 3.76 micron CMOS sensor. It's a backlit CMOS sensor and backside illuminated CMOS sensor. Sorry,
All good.
but and that allows us to have a really tight coupling between the two. Of course, with that high resolution CMOS sensor, yeah, you can technically fly higher to get the same GSD as you would with a lower level quality CMOS sensor, but at the same time, you got to have the resolving power of the lens to allow for that as well. There's a lot of atmosphere that starts coming, and it amazes me when I see the imagery that we collect from our drone versus the imagery we will collect from the air from an airplane, and while the resolution at the same GSD can be the same, I do feel like you can see just a little bit more detail, from the drone, just because it's flying at 400 feet versus like 1,500 feet from some of the other applications. So,
right. And one thing you mentioned there that I want to go back to real quick is a fixed focal length lens, because a lot of times when somebody buys something off the shelf, they're buying, a Sony or a Nikon or whatever, they happen to strap to their drone. It usually doesn't come with a fixed focal length lens. So you either have to buy one or you have to lock it down. And the drone's flying around and buzzing around, it's vibrating, even if you lock it down, you're going to have some issues to deal with that lens. So that affects the resolving power, like you said. So something certainly for people to consider. And then, a little bit about,
and even for,
yeah, go ahead.
Even for our UAVs, we do have a fixed focus 80 millimeter lens and adjustable focus 80 millimeter lens. For inspection applications, that
Sure.
adjustable focus is great. If you're looking at a tower or you're looking to inspect something, having that ability to adjust the focus or have the system adjust the focus for you is phenomenal. But if you're trying to map with that, then that becomes a problem. So that's why we do have the two variations, especially for our UAVs.
Right. And then let's talk about just a little bit about what used to be called a metric camera, but more talking about the way the product is manufactured and what type of specs it's manufactured to, so that atmospheric conditions don't affect it at different altitudes, therefore don't change the minutia of the focal length and things like that. So, how are your guys' sensors manufactured different than, say, just a commercial off the shelf system?
Well, there's certainly a lot more testing that goes into what we will send out as a product versus some of those others. We test the cameras in very rugged conditions.
Yeah, I mean, we're even talking about material. Cheap plastic versus aluminum versus something else that carbon fiber or whatever that changes the properties of the camera body itself. So those are the things that people need to consider when they're trying to make a repeatable mapping deliverable. Is what things are changing the dynamics of that camera mid-flight. And when you tend to go with a metal body or aluminum body or something like that, carbon fiber body, you're tend to hold that geometry better than, say, a lesser quality camera, right?
Yeah, certainly, and using the high quality aluminum, high quality everything. I mean, let's be honest. I mean, there's never the perfect. I mean, unless it's like made out of really rigid, heavy material that's never going to work well, especially on a UAV.
Yeah, weight
unless
is a factor.
Weight is a factor. So as cameras try to get lighter, as they try to get more efficient, smaller, there is always factors that have to be, put into your model, if you will, as far as what will change, but having that change repeatable. It's got to be, you have to be able to model it. You have to know what's happening with the camera, with the material, and know that it's going to change the same way every time.
Right.
So that's really important.
And we'll talk about that farther along, how software such as Correlator 3D can now handle those variations and recognize them and adjust for them. So even if you don't have the perfect camera, you don't have the most rigid system, we can still produce a high quality product. It's not like the old days of, stereo plotters when I was younger, that you had to have, diapositives, which were positives of negatives, on Mylar film, and you had to measure the fiducial corners, and, it was all a mathematical and a mechanical solution. And it was rigid. It was just rigid. So you could not handle any variation. It would just create float in your data set. Now we don't have that. We're using software to do this type of processing. So as long as we know what camera type we're working with in the software, we can compensate for some of those lesser quality problems in some of those. So I just wanted to point that out. But we are also talking about calibration. So, when you're working with a high quality camera, a large format or a medium format, a lot of times they'll come with a calibration report, or somebody will produce a calibration report for them. Whether you guys are working with Regal and they do it, or you guys do it yourself. And again, in the large format world, it used to be the USGS that did it, but they don't do that anymore. You are creating calibration to solve for all those issues, and you guys do that as well, right?
Yeah, we have the 3 calibration labs now. Yep. One at the factory in Japan, and then the one here in Colorado. Yep. Are the newest 2. So we've definitely increased the size and what we can do in those facilities. Little shameless plug, I guess. You can edit this out, but Phase 1 does have a user group meeting coming up October 17th through 19th. So we're going to be showing off the calibration lab and having a great meeting with a lot of our customers in person. So anybody watching wants to come, please let me know, and we'll get you information on it.
Absolutely, me included.
Certainly.
Yeah. So that is a mark of a quality camera. And again, if it's something that is not provided, software these days, be it SimActive or whoever, can also produce those calibrations for you. So to our users, aware of that. Then the next thing we would talk about is selecting a camera for photogrammetry. On your side, I don't know how much time you spent outside of sales in photogrammetry, but you've obviously dealt with a lot of customers and a lot of different variation in what they do, because we already talked about fixed focal length cameras versus adjustable cameras, and the reason you'd want one or the other. Fixed focal length you want for mapping, but that same user may be working on power lines and things like that, where they want a camera, especially on a drone that's got a gimbal and can turn all oblique angles. They may want a camera that's zoomable. So project types, I would assume that the users of your cameras are they even in the mapping or geospatial world are working on all kinds of different projects. So how do you guys guide them through the process of finding the right camera within just the stable of cameras that you guys produce? How do you guys go about that?
Yeah, well, we break it up, of course, kind of in the mapping and inspection realm,
Mm,
and can further break that down if we need to into manned and unmanned. But as far as inspection projects go, those are the ones that are, of course, UAV applications, and they're looking to do towers, transmission lines, things like that, that can be done in a single lift or two lifts with the UAV. Those that we do have some that have put these camera systems in a pod on a helicopter, and they want to be able to fly one length of a power line, looking oblique, and another looking nadir. So there are many applications there. We of course try to steer the inspection people into the adjustable focus
yep.
lenses, and if it's mapping, we stay away from that. And really, the whole topic of this conversation too is, does size matter? Phase one has a 50 megapixel, 100 megapixel, 150 megapixel. And, one of the things we haven't really talked too much on is, kind of merging a couple of the cameras together to create a larger footprint with our 280 megapixels. So we have a huge range of cameras that can be applicable, but in many applications, the 150 megapixel is kind of hits that sweet spot as far as, will it do it all? Yeah, it'll do pretty much everything you want it to do. And if you've got a larger area to cover and you're going to routinely do that, then let's look at the 280 megapixel camera system.
Yeah.
I should probably even throw out, that we do have the 880 megapixel, which is nadir and oblique. For those that are looking for doing more the 3D modeling of cities and towns and larger applications.
Right.
But still based on the same technology.
Right. And maybe that's a secret that a lot of people may not be aware of, is most of the large format cameras now that are out there, they're just a series of smaller cameras, that make up that large footprint. So that's certainly a need that the industry has had, and software and hardware have made that happen. So like you said, you can start with a 50 megapixel camera, and then you can go up to the larger format cameras that you guys have, plus oblique, to do a much larger footprint and create those 3D city models, if that's what people are trying to do. Interestingly, your 50 megapixel camera is, like you said, it's a great tool for, say, the drones and those type of systems. So I think you guys hit all of those areas. And the thing I always thought was, when people start talking about using a phase one camera, that to me says that they are either evolving from drones up to the next level, or they're adding that capability, with another medium format system. Because in all honesty, it's a lot less expensive to get involved in a medium format system than it is in a large format system, and you can do a lot of the same work. So to see the medium format technology evolve and take up a big chunk of that space is really cool. I see it that way. I don't know. I assume you guys see it the same.
Yeah, I definitely see it the same way. And whether or not it's putting the medium format camera on a small aircraft, that's one of the huge advantages, especially jumping from a drone to some of those medium format systems on either in a strut mounted pod or with a belly mounted gyro mount. You can fly a lot less expensive aircraft and cover the same area. One of my guilty pleasures, of course, is to use the imagery that collected either internally or externally to make mosaics and stay familiar with my photogrammetry roots.
Yep.
And so I enjoy doing projects for our different teams throughout the company. And the UAV ones are great, but it's just a lot of photos to cover what should just be like 2 or 3 photos from a manned aircraft.
Yeah.
So that seems to be the one deciding factor for me is like, man, this is great imagery, high quality, but there are so many pictures.
Yeah, you're absolutely right, and I would say that's always been one of the differentiators with Correlator 3D is that um, unlimited images. It doesn't matter to us how many images you import um, as far as the software goes, and even in the case of phase one, we were the first to import or to be able to import IIQ directly, so we could work with the raw data. And that's all great, and I love it. And we have distributed processing, so if you've got 60,000 images, you can process it no problem. But I look at it as you, and I go, man, this is a 1,000 image project if you just rented a plane and flew it a little bit higher. And with STCs for pods being out there, and there's options these days, it's not like it used to be 20 years ago. There are a lot of ways to get into mapping beyond the drone space in an affordable way. And I think the medium format makes that happen for sure.
Yeah, yep. It's certainly a good application and a great next step from the drone world.
Right.
But there too, I mean, you talk about photogrammetry and just to have that knowledge, software is great, but it's never just a black box. There's always some sort of background to it. So, there's always gives and takes with when you have a project and knowing what's wrong with it. So that's my only, hesitation I have on selling people certain things is, do you have the expertise to do it? The cameras can do a lot. Your software can do excellent things, but do you know what you're looking at the end? Keeping that to that quality is really important.
Yeah, I mean, certainly on our end, it's about is what you're trying to do designed to happen in our software. A lot of people want to do 3D city modeling, or more so utility inspection or something like that, which may go beyond the range of even of our software. It may be good for someone else's, but that's usually where we end up trying to help people out. You may not have the expertise to do all that, and you may not have the right software, and you may not have the right equipment. We just want to make sure that you can do the things that you need to do in our software and get the accuracy that you need. We'll point you in the direction of different software if that's what it takes for what you're trying to do. And I'm sure you guys are the same way. Yeah. So, other than that, I mean, again, when we talk about project type, if you're consistently doing large projects, then you probably shouldn't be looking at a drone or, that type of system. You should be looking at that investment in a medium format, or, subcontracting your work if you're a drone operator out to somebody who has a medium format camera, so that they can collect that data for you. You may even have the software. You may be using Correlator 3D and you can process the data. But again, you and I have seen it. Somebody will come to you with 10,000 images from a drone, and you're just like, you spent days doing this when you could have hired the guy down the street to do it with an aircraft and still process the data yourself. So those are always things that come up to me.
And that's the great thing about like Correlator 3D is, if you have a drone and you've collected phase one imagery with that, and you're used to ingesting those IIQs, it's going to be the same workflow. If somebody, flies it with a manned aircraft, the same workflow is going to apply. So that's a huge benefit. Yeah.
So that's the goal. And not that we're talking to people in this webinar who fly satellites, but again, that's how we got our start, was processing satellite data, and here you guys are now getting involved in throwing sensors up on satellites. that's
So maybe we do want to talk to people that fly some satellites,
well, we
reach
do.
out.
We do. Yeah, so that's really cool that even in that world where it takes a lot of time and a lot of technology to put something up in the air, these folks are contacting you guys to say, hey, you're the sensor that we want to put up there, which is really cool. And then the last thing I wanted to bring up is the integration part. We're seeing Lidar become more affordable, more compact. We're seeing it on drones, and in pod systems. But what's really cool is that they recognize, or the user recognizes, that although Lidar is great for creating surfaces and things like that, you still want that image to go with it. A picture is worth 1,000 words, absolutely, and a point is just a point. So combining the two, it seems to be the way to go these days. And man, I sure see your cameras being combined with, Regal systems and Optech systems and so forth.
Yeah, it's a great partnership with both of those companies, and on the UAV side and man side, the weights of the cameras are always a little bit challenging for UAV joint collection. But there's always great things coming out from phase one, and great announcements that will be coming forward, in the near future. So we look forward to both of those projects. My expertise, of course, is on the manned aircraft side. So, I love those integrations. I've always been imagery. I don't know a whole lot about the LiDAR side of things, but it always amazes me what can be done with those sensors, and then seeing the imagery on top of the data is just phenomenal.
Yep.
So
yep, and in correlated 3D, what we don't work with LiDAR data as far as adjusting it, modifying it, anything like that, but we do ingest LiDAR data, so you can use that as your surface rather than doing it from imagery. But more importantly, for people that have those dual sensor setups, we've got some awesome tools for colorizing those point clouds. And when you present your customer with a colorized point cloud, that can mean a lot more than just a bunch of classifications. So where that becomes really cool is when they have a high quality camera and a dense point cloud, and we can mate those together to create just an outstanding visual tool. It's not a 3D model, it's a point cloud. But color values on a point cloud are, to me, just as important as, say, a classification that somebody gave. It comes from cameras like the phase one, make that happen.
Yeah, certainly.
So I love having you on. Again, we're coming up to UAV Expo, and as you mentioned, you guys are going to have a user group thing in October. Are you got any big announcements, big plans that you're going to have for those shows?
Yeah, I definitely say there's some great announcements coming out. They'll be announcing it Energio the week before our user group meeting, so coming up nice and soon here. It's hard to believe that it's already in August. So
and we'll have a crew at Energio as well. So and like you said, it's September, October's coming up, and that also means that we're going to get into flying season. So people should be looking at what sensors they have and how they're going to process them. So Kevin, I appreciate your time. I know the folks that are here on the webinar appreciate it as well. I'm going to cut you some slack and let you go, and I will get into a little bit of a demo of how people deal with this stuff on the Correlator 3D side. So again, thanks for joining us.
Thank you.
All right, so over here in the demo world, let's look at how we set up a project. So they're all the same pretty much. I mean, as far as UAV and medium and large format. But let's take a look. We'll say medium and large format, and then we'll look at the number of cameras that we're going to add to the project. So obviously, if it's a single camera, like off a DJI or a Sony on a Wingtra or something like that, then your number of cameras is one. If you have multiple cameras, say for example with the phase one, with say a city mapper, then you're going to have multiple cameras. So we're going to say we're going to have 1, 2, 3, 4, 5. Okay, so we've got left, right, nadir, forward, backwards, or something like that. Then we would hit next, and you would add the files or the folder for that project. So if we looked at here, the phase one imagery in here, and here they're all divided out into, so we'll call this, we'll do aft first. All the information, obviously there's lat long, all this information here. So we can go ahead and add that. It's going to obviously take all that information. If for some reason you had a text file, then you could just import it here. And we'll just hit add. Okay. And the next thing we're going to do is hit next. And it's going to pull in all the camera information. And again, we'll hit next. And now it's going to want the next folder, which would be group 2, which would be, we'll go with forward. And we would go through this process for each image set. Here we go again. We'll skip to the final project parameters. So now you can see we've got our project loaded, our cameras are all set up. I can turn off the satellite view so you can see everything's set up. And if we look at the images, we've got them broken down into groups, and each one of those groups contains cameras that are facing a certain way. From there, you would go on to your aerial triangulation like you typically would. Let's go and look at the project as it is complete. And we can start by looking at the AT information. Here we go. And we can look at the final AT report. Of course, you can see that everything came in nice and tight, which is what we expect with phase one cameras. So we can look real quick at the AT report, and we'll go ahead and look here. No ground control points used in this project. We're just testing out the multi-array camera. So the quality assessment is excellent. And as we go through here, you'll notice in the bundle adjustment, everything's unconstrained. So we're looking at it that way. We held no values. And it'll give us the image adjustments. Now, as we're looking at multiple cameras here, it's going to give us an image adjustment for every camera. So you can see those adjustments for each one, and the omega kappa phi, all of these things. So again, we imported what was provided. We just tweaked it a little bit. Actually, we let the software do that, and then there's camera 5 right there. So that's one way to know what's going on and to know that you're working with multi-camera system. And here we go. As we look at it in more detail, we've got them labeled: the aft camera, the forward camera, all of that, the adjustments, the initial and the adjusted values, all the way across. And we shouldn't expect to see a whole lot of change here. Same thing for the left and the nadir sensor. And then the same thing for the right sensor. So you're getting all that information for every camera. And then it's always in the end, there's just a little bit of information on, which system you use to process it and so forth. So, that's how we keep track of what's going on in the bundle adjustment at the end of the project. As you're aware, we have one of those. The AT report is saved here in step 1. It's also saved in the folder, the correlated 3D processing folder, for you to access that information as well. So So let's go ahead and look at, what we received out of this project. So this one's actually an excellent example as we are using one of the Phase 1 City Mapper cameras. So we've got, as we saw earlier, imported the images, and the data set is right here. So we have 1, 2, 3, 4, 5 groups and cameras. So we have an aft camera, forward camera, a left camera, a nadir camera, which is currently turned off, and a right camera. So they're all represented here, and you can see some of the images here. So anyways, we have each different one, and we can actually go through and just manually select some of these. You can see we've got one here that's broadcasting down to the center of the project. Got another one here doing the same thing. And you can see this is actually the new NHL arena where the Kraken play. So that's a good little information there. We've got a couple of nadir photos. We've got nadir here. So we can look at all these, and you can tell by the pattern how far they're out, which direction they're facing. So if you click on any of them, it'll show you where they are, and it'll show you the position in here. So it's a great way to see it. So just quickly, let's just go ahead and turn off the imagery, and we can zoom in and take a look at the project. And let's just zoom in right here to the arena. And again, this is for 3D city modeling. So what we're expecting to try to find here is some decent modeling of these areas. And as you can see, it did a really good job here within Correlated 3D using our new algorithms for modeling to create those objects. And I can actually flip this around so you can see it this way. Here is the new Kraken arena, and you can see it from a few different angles. So that's in a nutshell how we would set up our projects in Correlated 3D for single and or multi-cameras. This one just happens to be, again, a Phase 1 City Mapper. They lent us the data set, so we really appreciate that. We like testing out new products and making sure everything works, and it does within Correlated 3D. I'd like to again thank my guest, Kevin Graville from Phase 1, for joining us. I'd like to thank you, the audience, for bearing with me as we get through this. I've thoroughly enjoyed it. This webinar will be turned into a podcast. The webinar and the podcast are available or will be available on our website, www.simactive.com, under the Learning tab. Thanks again for joining us.